Okay, so I postponed this example to our meeting today. It's a very important example. You have to keep it in your mind all the time. So guys, just a reminder. I think I need to. Yes, okay. To remind you that concrete consists of coarse aggregate, which is gravel mostly. We have fine aggregate, which is sand, and we have cement, and we have water. If you would like to start your mix, you have to tell me what is the ratio between these components: cement to gravel to sand to water. Probably mainly for the first three ingredients. So I can say 1 to 1.5 to 2. That means if you put 1 unit of cement, you have to put 1.5 unit of gravel and 2 unit of sand. That makes sense? So we have to define a ratio between these components. And we have to follow this ratio when you are mixing these ingredients together. Mostly the water can be defined with 2 ways. You can say, hey, for this mix, I will put, for example, 5 gallons of water. Or I can say water, cement ratio equal 0.4. What does it mean? It means based on the amount of cement, the ratio between water and the cement equal 0.4. So if you know what is the cement value, the amount of cement, you can figure out the amount of water that needed for this mix. So one more time, if you would like to define your concrete mix, if you open any research paper, any textbook, anything, they will define a ratio between the 3 main components: cement, gravel, sand, or sand and gravel, whatever the ratio. So we have, for example, this ratio 1 and 1.5 and 2. So based on this ratio, for example, if you put 1 pound cement, you need 1.5 pound gravel and you need 2 pound sand. And if your ratio between water and the cement is 0.4, if you have 1 pound cement, that means you need 0.4 pound water. That makes sense? That makes sense? This is how to define your concrete mix. As I told you, if you open any journal paper, any research, any textbook about concrete, they will define how to figure out the ratio between these components. So for our example, we have a concrete mix. And the ratio between cement and the sand and the coarse aggregate equal 1 to 1.6 to 2.6. One more time, that means by weight. This ratio is by weight. That means if you put 1 pound cement, you have to put 1.6 pound sand. You have to put 2.6 pound of coarse aggregate to finish up this concrete mix. If we go to the concrete lab, if we mix these components together, we are not mixing anything. No, we have to measure these components in a very special scale. And also we are given here water equal 5.8 gallon for each sack of cement. By the way, if you open Home Depot or Lowe's, and you will find mostly every sack of cement weight 94 pounds. Mostly every sack of cement weight 94 pounds. That means for every 94 pound of cement, which is one sack, we will add 5.8 gallon of water. That makes sense. This I'm trying to help you how to read your problem, how to read this issue, because this issue will face you many times when you are working as engineer and you are dealing with concrete. Before starting also, I would like to remind you for something which is very important. I covered it before in hydrology and hydraulic. We have a term here called specific gravity. We are given specific gravity for cement, 3.15. We are giving specific gravity for sand, 2.62. We are giving specific gravity for coarse aggregate, 2.65. What is the meaning of specific gravity?
How many times heavier it is than water?
Yes. Specific gravity in a very simple way equal gamma of this material divided by gamma of water. This is a ratio between the unit weight of your material, whatever the material, cement, sand, gravel, anything, and the unit weight of water. This ratio is called specific gravity. So keep in your mind gamma water equal 62.4 pound per cubic feet. So the gamma water is known. Gamma water is known. It's a famous material, water. If you know what is the specific gravity for any other material, I can figure out the gamma of this material. Keep in your mind this gamma, which is called unit weight, equal weight divide volume. So if you know what is the gamma of a material, if you know what is the weight of this material, I can figure out how volume of this material. So we have right now two terms. The first one is the meaning of specific gravity. For this expression, I can figure out the gamma of any material. Once you figure out the gamma of any material, I can use this expression to convert. If you have volume, I can convert it to weight. If you have weight, I can convert it to volume. Does that make sense? So right now, we are given specific gravity for cement. That means gamma cement divided by gamma water equal 3.15. I can remove gamma water and put 62.4. So I can tell you what is the value of gamma cement. I can grab my calculator. So gamma of cement will equal 62.4 times 3.15. I got 196.56 pound per cubic feet. At the same time, the ratio between gamma sand and the gamma water equal specific gravity of sand 2.62. If you remove gamma water and put 62.4, I can tell you the gamma of sand equal 62.4 times 2.62 equal 163.5 pound per cubic feet. Also, the coarse aggregate. Specific gravity is given 2.65. So gamma of gravel or coarse aggregate divided by gamma water equal 2.65. I can figure out the gamma of this gravel or coarse aggregate will equal 62.4 times 2.65 equal 165.4 pound per cubic feet. So this is the first step I will start with. I'm giving the specific gravity for cement, specific gravity for sand, specific gravity of course aggregate, so I can convert this specific gravity to unit weight for each material. Anybody has any questions so far? And keep in your mind this unit weight, which is gamma, can be used to convert. If you have one of these, if you have the weight, I can figure out the volume. If you have the volume, I can figure out the weight. Any questions so far from the first step? It's not a concrete course. It's something related to hydrology or hydraulic or material properties. Okay, second step. Just remind me, we have a ratio between cement, sand, and gravel. This ratio is 1, 1.6, 2.6. This ratio is given. This ratio is given 1, 1.6, 2.6. And this ratio is by weight. So I will assume, I will not assume one pound of cement. I will assume I have one bag, 94 pound of cement. If I'm using in this mix, 94 pound of cement. Why 94? Because 94 pound is the weight of one sack of cement. That makes sense? Actually, you can assume any weight, but let me start with a more accurate number, 94. That means we are using one bag of cement. Do you think how much weight of sand I need? Do you know how much weight of gravel I'm gonna use? Any help? Let's start with sand. Anybody can tell me how much weight of sand do you need to add to this concrete mix if you are using one bag of cement or one sack of cement? Guys, are you still here?
Yes.
So
Would you multiply the
we need to do what? We need to do what? Tell me, we need to do what?
Could we multiply the 1.6 times the 94?
Thank you. It will be 150.4 pound of sand. If you are using one bag or one sack of cement with a weight 94 pound, you have to use 150.4 pound of sand to keep this ratio as it is. Anybody can tell me how much weight of gravel we need? I need to multiply 94 pound by 2.6. It will be 244.4 pound. Everybody agree?
Yes, sir.
Thank you. So if you are going to use 94 pound of cement, which is one bag, I have to use this amount of weight for sand and this amount of weight for gravel. This is the weight I'm gonna use. Can you convert this weight to volume? How much volume in cubic feet of cement? How much volume of cubic feet of sand? How much volume of cubic feet of gravel? And don't forget we have water. I forget to mention this. How much cubic feet of water? So let me try it again one more time here. The amount of water I'm gonna use is 5.8 gallon for each sack of cement. I forget to mention this. So we are going to use one sack of cement with 94 pounds. Can you tell me how much weight of water? Actually, I cannot remember, but let me open Google. And ask Google to convert gallon to pound. So right now, 1 gallon equal 8.34 pound. How many gallon we have for this mix? Based on the given information, 5.8. So I will multiply 5.8 times how much? 8.34. That means I am going to use 48.3 pound of water in this concrete mix if you are using one sack of cement. So right now or so far, one bag of cement, which is 94 pound, will need 150.4 pound of sand, will need 244.4 pound of gravel, will need 48.3 pound of water. How did you get the water? The water information is given separately here. We are going to use for each sack of cement, we are going to use 5.8 gallon. This number is volume. So I used my Google to convert between gallon and pound. For each 1 gallon, you have to multiply it by 8.34 as a number to convert your gallon to pound. So the next step, okay, we have these values in weight. Can you convert it to volume? So
Yes.
94 pound of cement, how much volume? We are going to use the gamma for cement. 196.56. Remember, gamma cement equal 156 point, I'm sorry, 196.56, which equal weight of cement divided by volume of cement. I think based on this ratio, the weight of cement is 94. This 94 will give you how much volume? I can find it by dividing 94 divided by 196.56 equal 0.478 cubic feet. So this 94 pound, this sack of cement will give you 0.478 cubic feet volume. We are knowing how much, what is the gamma of sand. Do you remember that? Gamma for sand, 163.5. This gamma equal weight of sand by volume of sand. I think the weight of sand is 150.4. I can figure out the volume of sand from this expression. So I will divide 150.6, I'm sorry, 0.4 divided by 163.5, I got 0.919 cubic feet. So this one will give you 0.919 cubic feet. Can you tell me this weight of gravel, 244.4 pound, how much volume? Yes, I can. Gamma for gravel, I figured this out, 165.4. Equal weight of gravel by volume of gravel. I think the weight of gravel is, from this ratio, 244.4. I can figure out the weight of gravel equal 1.477 cubic yard. So 1.477 cubic yard. Okay, keep going. We have 48.3 pound of water. Gamma water is already known. 62.4 equal W of water by volume of water. I know what is the weight of water. 48.3. So the volume of water will be 62.4, 48.3 divided by 62.4, I got 0.77 cubic feet. So 0.77 cubic feet. This is the second step. Second step, one more time. I will put the ratio between your gradients, cement, sand, gravel. I will assume I have one bag of sand with weight 94 pound. So how much weight of sand I need, how much weight of gravel I need, and I will look for the information related to water. Water is given here 5.8 gallon for each sack of cement. So I will convert this number to how much weight. I found it 48.3 pound of water. Then I will convert each of these weights to how much volume you have. That means I can say for each one sack of cement, I can produce how much volume of concrete. I can produce for each sack of cement, I can produce 0.478. This is the volume of cement plus 0.919 sand cubic feet plus 1.477 cubic feet of gravel plus 0.77 cubic feet of water time 103 can give you what is or how much volume of concrete will be produced. Equal 3.67 cubic feet. Or equal 0.136 cubic yard. I divided this number by 27 to convert from cubic feet to cubic yard. One more time. Keep in your mind all of these calculations based on 1 sack of cement. I found this 1 sack of cement will need 94 pounds of cement, 154 pounds of sand, 244.4 pounds of gravel, 48.3 pounds of water. These weights will produce for cement only 0.478 cubic feet volume. For sand only 0.919 cubic feet. For gravel only 1.477 cubic feet. For water only 0.77 cubic feet. So if you add this number plus this number plus this number plus this number, I can tell you how much volume that 1 sack of cement will produce. Everybody agree with these calculations?
Yes, sir.
My question is, why I multiply it by 1.03? Anybody knows?
Train.
Thank you. If you go back here, we are given information. When you are mixing materials together, you should expect air can go inside this mix. So we have air content in this mix around 3% by volume. So if you mix cement with sand, with gravel, with water, you should expect air inside, air bubbles. The volume of this air represents 3%. So I have to increase the total volume of these ingredients by 3%. This is the reason why I multiply it by 1.03. So 1 sack of cement will produce 3.67 cubic feet of concrete. I divided it by 27, so I can say I can produce 0.136 cubic yard for each 1 sack of cement. Does that make sense? So I can say for cement, each sack will produce 0.136 cubic yard concrete. For sand, for every 150, let me go back and grab this number, 150.4. For every 150.4 pound of sand can produce 0.136 cubic yard of concrete. For gravel, let me grab this number. For every 244.4 pound of gravel, I can produce 1.136 cubic yard of concrete. For water, for every 5.8 gallon of water, I can produce 0.136 cubic yard of concrete. That makes sense for you?
Yes, sir.
Okay. Let me go back to the problem. This is what is the required. What is the quantity of cement, sand, coarse aggregate bound per every cubic yard of concrete? So for every cubic yard, if you would like to put here 1 cubic yard of concrete, how much or how many sacks of cement? I can figure it out. If you have 1 cubic yard of concrete, how much weight of sand I need? I can figure it out. If you have 1 cubic yard of concrete, how much weight of gravel? I can figure it out. If you have 1 cubic yard of concrete, how much or how volume or how many gallons of water? I can figure it out. So I can put here any amount of concrete you need to produce. For example, we are pouring foundation slab for your house. So this foundation slab will need, for example, 30 cubic yard. Put this number here. And how many gallon of water I need? So you can do cross like this. This number times this number equal this number times this number. So I can figure this out. Does that make sense? So this example or this problem is very important. This problem help you to figure out the amount, the quantity of cement, sand, coarse aggregate, water needed for your concrete pouring. How can I start? We have to find this information first. What is the ratio between these components? How much water I'm gonna use? And maybe we have air. So I first start to figure out what is the gamma of each material. Second step, I will start with my ratio. Assume we have one sack of cement with weight 94 pounds. So how much weight of sand, how much weight of gravel, how much weight of water. Then I will convert this weight to volume, to volume, to volume, to volume. Then I added these volumes together, multiply it by air content, which is 3% in this problem. Then I can figure out the total volume of concrete that can be produced with this sack of cement. I converted 3.67 cubic feet to cubic yard by divided by 27. So I can say the amount of cement can produce this volume of concrete. So whatever the volume of concrete you need to produce, how much cement, I can do it like this. The weight of sand can produce this volume of concrete. If I need to produce this volume, how much weight of sand, I can do my math calculation. If this weight of gravel can produce this volume of concrete, if you have this volume, how much weight of gravel, I can do my math. If this gallon of water can produce this volume of concrete, so if you have a new volume, how many gallons I can use? You are done. Any question? Guys, do you have any question regarding this example? This example, I'm not sure. I think you have one problem like this one in your homework, and you should expect one like this in your exam, because this problem is very important. To be honest with you, I found one of them in my PE exam. So it's a lot of calculations, as you see, but you have to finish up this problem in around 6 to 8 minutes to be able to finish up your exam. We have another example here. I think you are familiar with it. I think you have one like this example in your homework. This one. We have a steel rebar with gauge length equal 2 inch. This length equal to inch. And the diameter of this steel rebar 0.503 inch. So I can figure out the area, the cross-section area of this rebar, this area equal by divide 4 times diameter square. So this area will equal 0.199 inch square. And the length of this steel rebar equal to inch. And this rebar is or was placed under tension. We are conducting tension test. During the test, the machine can tell me how much force and how much corresponding elongation. Because under tension, the length of this sample or this steel rebar will increase. We have stretch. So we have elongation. So how much force? What is the corresponding elongation? These information are given in this table. So how much load? If the load is 0, we did not apply any load, the elongation is 0. When the load became 1.5 kib, the elongation became 0.0005 inch. These are the records from the machine. I need to plot the stress strain diagram for this steel material. Keep in your mind two important things. If you would like to figure out the stress equal force divide area. If you would like to figure out your strain, you have to divide your elongation divided by the original length. Your original length in L naught equal to inch. So I have the denominators for each of these two expressions. Here is 2 inch, and here is 0.199 inch square. What about the denominator? The denominator will be the records from this table, the records of this table. So how can I do this example? I will do it using Excel. So let me open Excel. Do you think we have Excel? I think. So in this one, I have load. In this one, I have elongation. Do you agree? So we have 0. Anybody can help me to figure out these numbers? 0 and what? Can you repeat them for me?
Yes, I have to pull up the other slide.
So you can?
Yes, I'm getting here.
1.5.
1.5, yes, sir.
Then 4.6.
2.6, yes, sir.
4.6.
How much?
No, the 2.6 is 4.6, not 2.6.
Oh, 4.6, okay.
No, 2.6. It's 4.6.
Oh, this one?
Yeah.
Okay. 4.6.
And then 8.
This one?
8.
8.
Mhm.
Else? What else?
11.
11.
11.8.
11.8.
11.8 again.
11.8 again.
12.
12.
16.60.
16.6.
20.
20.
21.5.
21.5. Yes.
19.5.
19.5. Yes.
18.5.
18.5. That's right. For elongation, we have 0. We have 0.0005, I think. 30.
Yeah.
And the next
0.0015.
0.0015.
0.0025.
25. Yes.
0.0035.
Yes, sir.
0.0050.
Yes.
0.0080.
Yes.
0.0200,
Yes.
0.04,
Yes.
0.1,
0.1. Uh-huh.
0.28,
Yes.
0.4,
Uh-huh.
0.46.
Yes, sir. Thank you. So these are the records from the machine. I will start here to figure out what is your value of stress. If you would like to figure out the value of stress, we need to divide your recorded force by the area, which is 0.199. So I will come here and put equal 1 equal and divide this number. I will not write 0. I will just click on this cell. So it's written D6. D6 means D is the number of column, 6 is the number of row. D6 divided by, where is the divide? Do you think your divide is this one or this one? I think this one. Let's try. 0.199. Enter. There you go. So 0 divide 0.199 equal 0. If you double click here, you can repeat this information here. This number divided by 0.199 give you this number. This number divided by 1.99 give you this number. This number divided by 1.99 give you this number, and so on. If you would like to figure out the strain, your strain, let's go back here. If you would like to figure out your strain, you have to divide the elongation records divided by 2 inch, which is the original length of your sample. So I will come here and write equal. Equal what? The value of elongation, just click on this value, divided by 2 inch, divided by 2 inch, the original length. Enter, then go back to this cell, just double click at this corner. You can repeat the calculation to all of these cells. So I divided this elongation by 2, give you this one. I divided this elongation by 2, which is 2 inch, give you this one. This one by 2, give you this one, and so on. So right now, I would like to plot the stress-strain relationship. We have stress, we have strain. If you would like, we can highlight them. And because I don't have my calculator. Let me. Yeah. I can do here, right click and format cell. Fill, you can highlight these two with this color. There you go. Okay, so I would like to plot the relationship between stress and strain. Strain on the horizontal line and stress on the vertical line. I can go here for insert. We have this little arrow. If you open it, I can use this. One more time, if you would like. Insert. We have here this plot. If you open this arrow, this little arrow, I can use this one. Put your points and connect between them with a curve. Right click on this plot and then select data, add. For the x-axis, for the x value, I will select the column of the strain. Enter. For the y values, I will select the values of the stress. Then I can say, okay, okay, you have your diagram. This is the relationship between stress and strain of steel. If you remember last meeting, I told you, if you try to draw a relationship between stress and strain for steel, strain on the horizontal line, stress on the vertical line, your curve will be something looks like this. And we have many information. We can figure them out. The most important information from this curve at this plateau, which is horizontal, we have a value here called F yield. Anybody in this room can tell me what is the value of F yield? Any help? Around what?
60 looks like.
Yes, thank you. Your F yield from this is Y equals 60 P, no, not B, KSI. Do you know why it's KSI? Because your force in this example in kip, your area in inch square. That means your final stress value will be KSI, kib per square inch. Kib per square inch. This is called KSI. If you remember also, the slope of this linear relationship is called E, Young's modulus of steel. We have a linear relationship. At the beginning of the relationship, it's linear. If the slope of this linear relationship will give you the slope of steel, it will be around 30,000 KSI. Roughly, will be around this number. If you would like to figure out the highest value of stress that we can reach, this is called F ultimate. This is the ultimate value of stress we can reach. Anybody can tell me what is the ultimate stress here in this curve? I think the highest value, this point. How much at this point? 108. This is the highest stress we can reach, 108. KSI. That makes sense. I think you have one like this in your homework. I prefer if you can provide me with the curve using Excel. So right now you are senior students, you are professional in everything. So I do prefer in your homework, go ahead and print this table for me in your homework and put you this diagram. If you open your Word, because you are going to submit your homework via D2L. If you go to Excel, you can highlight, select this table, copy. If you go to the Word file, right click, and you can select paste like picture. It's a picture right now. Does that make sense? You can put it anywhere. And also, if you would like to go to the Excel, select this diagram, copy, right click, and put it here as a figure. There you go. Does that make sense? This is how to solve your homework for this type of problems. If you would like, if you have more, if you are familiar with Excel, you can adjust this X, double click on this X axis. You can make it line here, make it with a color solid, and make it thicker like this. And from this one, track not, a label not. I think this one, yes. A major type, you can make it inside, so you can put these markers. And also the same for this one, you can put markers and go back here for the line to be solid, black, and make it thicker. There you go. That makes sense. If you would like, you can select your chart, and we have here at chart element, you can add axis title, primary horizontal, you can say strain. So you can write a title for the horizontal. If you go back here and select axis titles, primary vertical, you can write stress. So you can write the title for the horizontal and the vertical one, and so on. Does that make sense? Do you
Yes,
have
sir.
any question regarding this example?
No, sir.
The last example I would like to cover today, which is piece of cake. If we would like to make combination, we have combinations for the first method of design, which is ultimate limit state. We have another combinations. You don't need to remember all of these. All of these are already included in the standard. We have another combinations if you would like to use the allowable stress design. So for example, if we have this one, we are given the value of the life load on this column. We have 300 kib. That means the value of L equal 300. And the value of the dead load equal 150. And the value of roof life load equal 60. And the value of the wind load equal 70. And the value of seismic load equal 50. Looks like we don't have sand. I'm sorry, we don't have snow. Your snow is 0. We need to figure out the worst case using the load combinations according to ASC E7. Okay, the problem is giving you these values. What you need to do only go ahead and put D here equal 150. What is the final value? 1.4 times 150. How much? 1.4 times 150 equal to 110. For this combination, your dead equal 150. Your life equal how much? 300. 0.5 time, which one is bigger? LR or S? Your S here, we don't have snow, so it's 0. So I'm gonna use LR. LR equal 60. If you have both of them, which one is bigger? So go ahead and multiply 1.2 times 150 plus 1.6 times 300 plus 0.5 times 60 will give you a number. And next combination, you're dead 150. We have LR and S. We don't have S, it's 0. So I'm gonna use LR, which is a bigger 60. We have L or 0.5 W. Go ahead and do your math calculation. Your L is equal 300. 0.5 W will be 35. So I'm gonna use L, which is a bigger. So I have another value. The same here. I have a value. The same. I have a value. I have a value. I have a value. So I can figure out the value of each combination, which value I'm gonna use, the worst case, which is the biggest one. It's piece of cake, just piece of cake. How to figure out these numbers? Life load equal 300, 150, 60, 50, wind load 70. This is a different story. This is coming from structural analysis and the software, and we need to define case of loading. We will cover all of this. But so far, we have ready values for each of these categories: dead life, roof life load, snow, wind, earthquake. Then I need only to grab these numbers and put them in this combination to find out the worst case. Exactly the second question, the second example. I'm giving you the life load, dead load, roof, life load, wind, seismic, and we don't have snow. Just to go ahead and put these numbers in this combination. The first combination will be 150. The second combination will be 450. The third combination will be dead plus LR. It will be 210. What is the next value? What is the next value for this combination, this combination, this combination? Then I can use the biggest one.